Hi, in this video I'm just going to be going through a question from June 2011, question 6C, and it's a complex ion type question. And it's looking at 2,2-bipyridine. It's a bidentate ligand, so we've got two coordinate bonds can be formed, one on either nitrogen. And the name of the bipyridine, the number start the carbon atom that links to the other ring. So we've got 1,1. And so this becomes 2,2-bipyridine because the nitrogens are on the second, are both on the second carbon along. So 2,2. Forms complex ions with nickel, and they're shown below. So the first thing we need to do is look at the formula of bipyridine. And 2,2-bipyridine has 1, 2, 3, 4 carbons there. Sorry, 5 carbons there. And 1, 2, 3, 4, 5 carbons. So part 1, that's C10. There are only hydrogens here, 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 and here, and here, 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 and here. So only 4 hydrogens on each ring. So that's H8. And then we've got 2 nitrogens, so N2. In part 2, it asks what's the coordination number of the nickel complex ion. And we've got 1, 2, 3, 4 coordinate bonds. So the coordination number is 4. In part 3, it tells us that 2,2-bipyridine forms a complex with a transition metal ruthenium with the formula ruthenium Bipy3. So there's 3 of them, 2+. The complex exists as 2 stereoisomers. So draw a 3D diagram of both those stereoisomers. So I'm going to draw a simplified version of this. And we have ruthenium in the center, and we're going to have 3 of the 2,2-bipyridine bonded to it. So that is going to create an octahedral structure. So what I'm going to do is I'm just going to join this up with this one, this up with this one, and this up with this one. And that represents each of my 2,2-bipyridines attached to the ruthenium. So I've got 3 attached, each of them attached twice because they've each got those 2 nitrogens. Then I'm just going to create a mirror plane of this and put ruthenium in again. And this time I'm going to put, this bond was here, so the mirror of that would be there. A bond going backwards there, my 2 straight bonds, bond going towards us, bond going away for us. So I've got the mirror image there, but the way the bonds line up are now slightly different. So we get the mirror image and we get stereoisomers there of the ruthenium complex ion, and they won't be superimposable on top of each other. So next up we've got 4,4-bipyridine. So they've changed the structure in part 4. It's now 4,4-bipyridine. So 4,4-bipyridine is going to have the nitrogens on the 4th carbon. And so complex ion can go that way and that way. And so this can create a bridge between different ions. So it can form coordination polymers. For example, nickel can form a coordination polymer with 4,4-bipyridine containing nickel and 4 waters, and they're 4,4-bipyridine chains. Draw a 3D diagram to predict the repeat unit in this coordination polymer. So we're going to have nickel, and that is going to bond with a coordination bond with just 1 at the moment of our 4,4-bipyridine. And so that can continue on, and we could then get another nickel this way and then carry on, and we get a chain of the polymer then formed through that coordination bond. But that's going to be my far end. Then this way the nickel can join with another one of the 4,4 bipyridines. So that would be that way, and what you get there in the polymer is another one of the 4,4 bipyridines. And then here we need 4 waters as well. And so we've got 6 bonds in total. That's going to be our octahedral structure again for the waters. And there were 4 of them. Yeah, so 4 waters added on here. Making sure the bond is to the oxygen. And so that'll be N. And was it 2 plus or 3 plus? 2 plus. So that is our repeat unit for the coordination polymer.